I'd like to do an example of translating English sentences into mathematical notation using predicates, quantifiers, and implications. So here are four predicates. P of x is a hummingbird. Q of x is large. R of x is x lives on honey. S of x is richly colored. And the domain here, this is where x is coming from, is the set of all birds. Okay? So here's a statement we'd like to translate into mathematical notation. All hummingbirds are richly colored. Okay, so how do we write that all hummingbirds are richly colored? Another way to think of this is, well, for all birds, if you're a hummingbird, then you are richly colored. So by that logic, for all x, if P of x is true, if you're a hummingbird, this implies that S of x is true. You're richly colored. Okay. How about no large birds live on honey? So no large birds live on honey. Okay, well, this means that it's not the case that you can be large and you can live on honey. So it is not the case that there exists a bird that's large and lives on honey. Okay, how about this one? Birds that do not live on honey are dull in color. So birds that do not live on honey are dull in color. Okay, so that means that for every bird, if you do not live on honey, that implies that you are not richly colored. Okay, so being dull in color is, we're assuming here, is the opposite of being richly colored. One more example. What if you wanted to express hummingbirds are small? Okay, and by small here, we mean not large. So the way we'd write this is that for every x, for every bird, if you're a hummingbird, this implies that you are not large, i.e. you're small. Okay, so this is the correct answer. A wrong answer would be for all x, P of x, and not Q of x. This is the wrong answer. This means that for every bird, you're a hummingbird and you're not large. So this would just say that this would express the idea that every bird is a hummingbird and it's small. But you know, there are some birds that aren't hummingbirds, so this isn't the right answer.